Most people understand that open source software is software copied for free. What's less understood is how the potential chaos of all these copies can be transformed into a collaborative whole. Let's break down how open source works, using a family cookie recipe as a metaphor we can all relate to. Just like code, all recipes start by somebody writing the original version. In this case, Grandma May has developed a delicious cookie recipe. She shares it with her family, telling them they can use her recipe as long as they follow her rules. In Grandma May's case, anyone who bakes cookies with her recipe has to credit her as the author. And if they make changes to her recipe, she has to be allowed to use those changes in future versions of the recipe. The same thing happens when someone writes and publishes an original version of open source software. They put rules, called licenses, in place so that others can use and change the code they've written as long as they follow the author's license. Grandma May's recipe provides her family with a place to start that they can customize to their own liking. Aunt Maria decided to add chocolate chips to her batch of cookies. In software, this departure from the original code is called a branch. Aunt Maria's change was such a great success with everyone who tasted the cookies that she asked Grandma May to add chocolate chips to her original recipe. At this point, Grandma May needs to begin acting as a maintainer, looking after the integrity of the original recipe and deciding which changes she will incorporate. In this case, Grandma May agreed that the chocolate chips were a good addition, and so from then on Grandma May's recipe included chocolate chips. Aunt Maria is now a contributor because she has contributed something to the recipe. In open source software development, this process of incorporating a change or patch into the original code is called upstreaming because it's flowing back to the original source. If the original brand of chocolate chips becomes unavailable, Grandma May is responsible for updating the upstream chocolate chip patch with a new brand because she accepted the patch. The benefits of incorporating your changes into the original recipe are pretty amazing, leading to the popular open source motto, upstream early and often. The sooner you upstream, the sooner the community can back you up, not only by maintaining the recipe, but also by testing it in as many configurations as there are community members using it. Uncle Miles went out on a limb and added peanut butter and nuts to his batch of cookies. His wife and friends all love peanut butter, so they thought his additions greatly improved the original recipe. But when Uncle Miles tried to upstream his nutty changes, Grandma May, who detests peanut butter, refused to add peanut butter and nuts to her recipe. Uncle Miles resolved to move on with his version of the recipe with no plans of merging the two again at any point. In open source software development, a permanent split like this is called a fork. Grandma May's recipe is getting better all the time, as people continue to contribute. Her family gets to learn from and enjoy the latest and newest cookie recipes as they are created. As Grandma May's family grows and her recipe is shared outside the family, more and more people will become contributors. As you can imagine, things could get pretty complicated for Grandma May as the maintainer of the original recipe with more contributors. The same is true for open source software. More contributors and more versions of code make it essential that we have a way of collaborating on changes. This is why we need the structure, common language, and roles we just talked about with our recipe example. Now let's recap really quickly. Someone writes an original version of the open source software. They set rules around how it can be used and changed called licenses. This gives contributors a starting point to then branch out from and make changes or patches. Some request their changes to be upstreamed to merge their new version with the original version. If the maintainer decides to incorporate the change, it becomes part of the main branch and will be maintained by the community even if the contributor stops being involved in the project. Actual products based on open source can be made up of dozens, even hundreds of recipes like Grandma May's, which is why having a disciplined way of managing change is so important. In open source, the possibilities are endless.
Static versus dynamic website. Ever notice how contents on some websites do not change at all? And, on the contrary, how websites like Facebook change their content almost every second? Well, not every website is the same, and depending upon the requirements, websites can be either static or dynamic. A static website pretty much remains the same over time. This means any change that needs to be done to a static website can only be done by modifying its HTML codes. A dynamic website, as the name suggests, is dynamic or not static. Its contents can change dramatically. Dynamic websites relay contents from an underlying database, so every time you change the database, you change the website contents. What's better in what scenario? Static sites are known for their speed, and dynamic websites for their content management system. Static pages load faster, but the design is usually minimalist. Dynamic pages are interactive and more appealing than their static counterparts. Websites that have the provision for user accounts are bound to be dynamic. So, which one is better? For a simple, basic website that would not need to change its content very often, static is the ideal choice. However, if your website requires users to log in and you're going to revamp the content every now and then, a dynamic model should be your go-to. To know more, subscribe to SciFuture's YouTube channel. SciFuture, thinking future, moving ahead.
What's a static website? A static website, by definition, is any site that has fixed or stagnant content, usually written in HTML code. A dynamic website is a site whose construction is controlled by an application server processed by its server-side scripts. What do I mean by this? Number one, what this means, in a dynamic website, pages do not actually exist and they're not saved separately. What does exist is number two, the design files or the template files. The template files govern the look and the feel of the website and the structure of how you want to organize it. The corresponding content for a specific page, they are saved in databases and that's saved separately. So what happens is any request to view a page of a dynamic website automatically populates all this information together and puts them accordingly so that you can view the page.
What is a server? In computing, a server is a computer program or a device that provides functionality for other programs or devices, called clients. Servers can provide various functionalities, often called services, such as sharing data or resources among multiple clients or performing computation for a client. A single server can serve multiple clients, and a single client can use multiple servers. A client process may run on same device or may connect over a network to a server on a different device. Typical servers are database servers, file servers, mail servers, print servers, web servers, game servers, and application servers. Let's look into the top 8 server definitions. Let's start with file server, a computer and storage device dedicated to storing files. Any user on the network can store files on the server. Print server, a computer that manages one or more printers, and a network server is a computer that manages network traffic. Web server. Web servers are computers that deliver or serve up web pages. Every web server has an IP address and possibly a domain name. There are many web server software applications, including public domain software and commercial packages. Database server, a computer that processes database queries.
What client-side and server-side does actually mean? Client-side and server-side are web development terms that describes where application code runs. Well, some web developers refer client-side and server-side as front-end and back-end. Although they aren't quite same, don't confuse with the terms. Now, what is scripting? Scripting means all the series of commands that are able to be executed without need of compiling. Note, as all scripting languages are programming languages, but not all programming languages are scripting languages. But now you may ask, as we know compilation is not done in scripting language, then how conversion of higher level language to lower level language takes place for execution? It takes place with the help of interpreter. So far so good. Let's see the difference between client-side scripting and server-side scripting. Client-side scripting simply means running scripts such as JavaScript on the client device, usually within a browser. For example, the project we did in last video, in that we did a simple user validation form, where the form validates the user entered data on the client side only, where server-side script runs on the server instead of the client, often in order to deliver dynamic content to web pages in response to user actions. Suppose a user enters a username and password and hits a submit button. Then request from client side goes to the server side and all the processing has been done here, and then server responds to the client with the result of the processed data. Now what technologies and languages does client and server use? Client uses this mentioned browsers, namely Chrome, Edge, Safari, Firefox, and it uses languages like HTML, CSS, JavaScript, where server uses a web server like GoDaddy or any other hosting services, and it uses databases like MySQL, MongoDB, Oracle, and more, and it makes use of languages such as Java, C#, and more.
So the question is what is an Apache web server? An Apache web server is an HTTP server that presents websites to visitors that come to your server. So if you want to deploy a website for a business or for your organization, you would most likely use Apache in order to do that. There are other HTTP servers out there, such as IIS or Nginx, but Apache is the standard that most people use, whether they're on Linux, whether they're on Windows, or whether they're on Mac. Apache is the default that most people go to because it's well known, it's very reliable, and it's free. So if you're going to be trying to deploy a website, generally you're going to be using Apache. Now, one thing to realize with Apache is that all it is an HTTP server. So if you install this onto Linux, or you install it onto Windows, or you install it onto a Mac, all it will allow you to do is be able to present static websites to visitors coming to your server. So if you code out an HTML website with no additional programming languages other than something like JavaScript, you can use that with just an Apache server. So H1, title, you plug all of that in, you can put that onto an Apache server, and you can present that to visitors coming to your site. Do realize if you need any database services or if you need a dynamic programming languages, in order to make your website work, such as PHP or Ruby, something along those lines, you will have to install those additional server services onto your server. So most of the time when people build a web server, they build a LAMP server, so a Linux, Apache, MySQL, PHP. Generally, most of the time people install MySQL and PHP in addition to Apache, but do realize that you don't have to. If you just simply have a static website, maybe with specific information, a very plain, general website, you can simply use Apache in order to present that to your visitors. So that
video is about an introduction to localhost. In computer networking, localhost literally means this computer. When you type a URL into your browser, you are essentially connecting to a host computer somewhere else in the world. This computer serves you the web page that you requested. If you type localhost into your browser, however, then your browser will know that you want to connect to the computer you are currently using. If your computer is running web server software like Apache, then your browser will be served a web page by your own computer, which is otherwise known as the localhost. Every computer connected to the internet has an IP address, and your localhost has one too. Localhost is often used for testing and development. When a developer installs WAMP, LAMP, or MAMP software stack on their personal computer, then they will typically type localhost into their browser in order to pull up their WordPress website. Local server environments can speed up the development time. It is also great for learning purposes. Now you understand that localhost is not merely a technical term for your computer. It is a default name that enables you to test programs and even close access to websites.
Is all around us. We used to store data on paper in big filing cabinets, but eventually we stored them online in what we call databases. How do we easily pull the data we want to look at it? That's what SQL is for. It's a language that communicates with databases. SQL stands for Structured Query Language. People call it SQL or SQL. In short, SQL is the name for a language that is used to communicate with databases that store your data. If you want to pull, edit, add information to a database, you can use the language of SQL to do that. But how does SQL work? Think of a database like a warehouse, data tables like filing cabinets, and data like files. This warehouse or database stores data. The warehouse database was built using coding languages like C++ or C or Java. Now imagine regular Lego people need to access the files. How do they do that? Option 1, you could have a storefront built to the warehouse so that customers can ask for files, add files, delete files. But essentially this means you are building something that takes a lot of time, money. In the real world, this is the equivalent of building a whole app just to access the files in the database. SQL comes in, which is the second option, SQL. This is like you hiring a specialized delivery translator. Her name is Sally SQL. She knows how to talk to the database, and she knows how to speak in the language of SQL. So if you learn to speak SQL, then you can ask her to get files for you. Okay, so how do you speak Sally's SQL language? Here are the requests you could make. If you're a Lego mayor, you want to know the name of your citizens, you'll ask Sally SQL, select name from Lego people. The request to select name, that column, from Lego people, which is the name of the table. Or if you're a Lego doctor and want to know the name of citizens that are higher than 3 centimeters, you would ask Sally SQL,
select name from Lego height, where centimeter is greater than 3.
She returned 2 Lego people, Sarah and Craig, because their centimeters is greater than 3, and she pulled from the name column within the table called Lego height. Or if you're a statistician and you want to know both the height and age combination of citizens, but this data is stored in 2 separate tables, here's what you'd say to Sally SQL. Not all tables are found together. Sally joined the two tables because what both two tables had in common, a names column. She was able to join the two, matching by the names in each table. But you can also do other things. You can add data if you want to add Joe, who's age 12. Or you can update data, make Joe 13. You can also delete Joe altogether. From creating tables to joining tables to altering tables, Sally SQL can do it all. So here are 3 things you need to remember about SQL. 1. SQL is the one language you probably should learn. If you are in business or marketing or sales or anything that you wouldn't normally think you need to learn to code, SQL is the one language you probably should learn. The reason why is because most companies nowadays have an online presence and are keeping records of data on a database. So the more you know how to communicate to this database and pull data, the better you can be at your job because now you can pull the data, analyze it. 2, SQL languages have variations. Different companies with different SQL databases have different SQL syntaxes. There's small variation, so it's the equivalent of having different Sally SQL bots with different accents. 3, SQL only speaks to a specific kind of database called a relational database, which is essentially a database that has a tabular schema. So it's a lot like a data table with rows and columns.
Welcome to this tutorial series on SQL and database. But before we learn about database, let's understand what is data. In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. are some data related to you. A picture, image, file, PDF, etc. can all be considered data. Now, what is a database? We already know what data is, but this data could be random. A database is a systematic collection of data. Since the data in a database is organized, it makes data management easy. What is a database management system? DBMS. Database Management System, or DBMS, is a collection of programs which enables its users to access a database, manipulate data, and help in the representation of data. It also helps control access to the database by various users. Let's discuss a few examples. An online telephone directory would definitely use Database Management System to store data pertaining to people, phone numbers, and other contact details. Your electricity service provider is obviously using a DBMS to manage billing, client-related issues, to handle fault data, etc. Let's consider the Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisements, and a lot more. We can provide countless numbers of examples for usage of DBMS. Relational DBMS. This type of DBMS defines database relationships in forms of tables, also known as relations. Unlike the network DBMS, our DBMS does not support many-to-many relationships. Relational DBMS usually have predefined data types that they can support. This is the most popular DBMS type in the market. Examples of relational database management systems include MySQL, Oracle, and Microsoft SQL Server. So what is SQL? Structured Query Language, SQL, pronounced as SQL or sometimes as SQL, is actually the standard language for dealing with relational databases. SQL can be effectively used to insert, search, update, and delete database records. That doesn't mean SQL cannot do things beyond that. In fact, it helps in optimizing and maintenance of databases and much more. Relational databases like MySQL, Oracle, MS SQL, Sybase, etc. use SQL. SQL syntaxes used in these databases are almost similar, except the fact that some databases use different syntaxes and even proprietary SQL syntaxes. An example of an SQL statement: select star from members where age is greater than 30. DBMS stands for Database Management System. The most widely used DBMS is the relational model that saves data in table formats. It uses SQL as the standard query language. SQL is the standard language used to query a database. The database approach has many advantages when it comes to storing data compared to the traditional flat file-based systems.
Hi there and welcome to my channel NowRemi Official. Today we'll be learning about the 4 local servers XAMPP, WAMP, LAMP and MAMP. Local servers that are used while developing PHP sites. Using these servers, programmers can test a website locally before they upload it to the main server. This ensures that the new website doesn't have any bugs or errors.
A session is a way to store information to be used across multiple pages. When you work with desktop applications, the computer knows who you are and how long you are using that application. But web servers are slightly different. Web servers don't know who you are and how long you have been working on a website because the HTTP servers are stateless. They don't store user information. They only get the request from the client and send a response. Session variable solves this problem by storing user information to be used across multiple pages. By default, session variables last until the user closes the browser.
Session is basically a way to establish a state for a user or for a request. So every time a request is made from the address bar to the web server to serve certain pages, web server has no idea who you are, has no idea whether you're logged in or you have the permissions to check this page. It's going to look for that asset you requested and present it back to the browser, which is rendered. So HTTP being stateless, sessions were invented, which basically gives us a way to identify a user. And if the user has the permission, we can write that logic and we can say, okay, you can access the page or you can't access the page. And we can also maintain their session length, the time, and if they didn't do any activity for a certain time, we can log them out automatically and request them to verify again. So a bit of security, bit of restriction.